Hello, ladies and gentlemen. We will start the session using Algorithmia to leverage AI and machine learning APIs, which will be given by Kenny Daniel, the founder and CTO of Algorithmia, with which he has a goal to accelerate AI development by creating a marketplace where algorithm developers can share their creations and application developers can make their applications smarter by incorporating the latest machine learning algorithms. Now let's give him a big applause. Welcome.
Thank you. Thank you for everyone attending my session, and thank you to Rakuten for hosting a great conference. I've really learned a lot from the sessions I've been able to attend so far today. So I'm going to be talking about leveraging AI and machine learning APIs with a bias towards Algorithmia because that's what we do, but it's by no means limited to just Algorithmia. I want to talk big picture about kind of the direction that I see machine learning and AI going. So let me start off with just a little bit about myself. My name is Kenny Daniel. My background is in academia, in artificial intelligence and machine learning research. Ever since I first heard about and learned about AI, I've been fascinated by it, and so I went and studied it in undergrad and then also in graduate school after that, developed various algorithms, published papers, and so on. After graduate school, I continued in the field. I worked in various startups actually implementing AI and using it in real-world products. And since then, I've taken what I've learned over the years and applied it to my own company that I'm the co-founder of, Algorithmia, where we're trying to bring AI and machine learning to a much wider audience. To fill you in a little bit on what Algorithmia is and what we're trying to do with the company, just for some context, my personal experience in academia was developing algorithms, and myself and my colleagues do this all the time. And the problem is that over and over again, I saw this state-of-the-art, really great work that was really pushing things forward in the field, ending up just stuck in the lab or just stuck in obscure academic research journals. And it was frustrating seeing this with work that could really benefit companies and applications around the world. And so that's where the idea for Algorithmia was really born out of, was can we create a marketplace, or can we create a system to take work not just from academia and from research, but really from any developer anywhere in the world. They take their code, upload it to the Algorithmia platform. We take that code, we compile it, we deploy it to our compute cluster, and we make it available as a service through REST APIs that anybody can tap into. So the goals with this are a couple things. For one thing, on the user side of the platform, is that any company or individual or application can tap into the state-of-the-art in machine learning and artificial intelligence. So whether you're developing an Android or iOS app or building commercial scale deep learning systems, you can tap into the work that's being done by researchers around the world. For the algorithm developer side, or for the researcher side, this allows a new venue for them to actually commercialize and monetize their work that didn't really exist before. There wasn't really a good outlet for this sort of thing prior. The academic publishing cycle doesn't even really have a great way to publish code in a standard way that people can consistently call, or even to compare different work between different labs. And services like GitHub and things like that are a great resource, but they don't go as far as you would want. You can't immediately start using or immediately start calling things that are available on GitHub. You have to jump through a whole bunch of hoops before you can even start using code from there. And then big picture, really the goal is to bring all of these individual AI modules, as we call them, or building blocks, in one place, because it's very rarely just one algorithm that you need to solve your problem. A lot of the time, it's going to be a combination of things like natural language processing to make sense of text data from the web, or image recognition algorithms to make sense of images and video. And you want to have them all in one place and be able to combine them so that you can build more and more powerful intelligent systems on top of these building blocks. So I talked about a couple of things. We really look at this very much as a building block problem, and there's a variety of things. Things like recognizing patterns, recognizing images, making sense of the massive amounts of text that are out there on the internet. understanding audio and natural language. These are things where research has made huge strides in recent years, and a lot of companies, things like Google, are really leveraging these to make intelligent applications that consumers love. So now that you know a little bit about who I am and what Algorithmia does, really the subject of the talk is the future of machine learning and how it gets incorporated into products and applications. And to draw an analogy to just a few years ago, actually, before AWS and cloud computing was huge, most people had servers in their basement in their businesses and managed their own servers and had a whole team of people dedicated to managing those things. And even once services like AWS came out, there was still initially a lot of resistance to that and people reluctant to dive in. But nowadays you look around and it would be crazy to run a business or start a business, certainly, without using these kind of services, because it's just an entire skill set that you don't need to have. You can just use it as a service available. And machine learning, I expect to follow a similar trend. Right now, a lot of AI and machine learning is done by big companies that have in-house teams dedicated to it. And those are the big companies that you think of: Google, Amazon, Facebook, Rakuten. They can afford to hire internal teams of PhD researchers straight out of university or wherever. But there's not enough people studying this field to go around in the world, to all the hundreds and thousands of companies that would benefit from having access to these tools. So there's a huge shortage of talent. The algorithms are becoming more and more standardized. That's not to say they're a complete commodity or that it's one size fits all, but it's starting to head more and more in that direction, that algorithms are able to solve a wider variety of problems, and a lot of the time it's the data that's changing, it's not actually the algorithms. And then finally, the other benefit, again analogous to how cloud computing has come to be, is the desire for more rapid iteration. The sort of standard way of running a machine learning lab would be, you try something out, you implement an algorithm, you throw your data at it, you see if it's going to work for you. But if you're implementing all those algorithms from scratch, that's a huge amount of time invested just to see if you're even going to get results that are useful for you. So this is an acronym that I heard earlier this year and I really liked it, GIFY, Google Infrastructure for Everyone Else. The context that I heard this in was actually more about container orchestration and Docker and the way that they slot their services into their infrastructure. But I think that there's also something to be learned from how they do machine learning and AI. And that is, if you're an employee at Google, they have all these amazing services available, things like mapping and image recognition and translation. And then you could just tap into and incorporate them into your products. And I think that that's generally the way that companies are going to be going in the future, is that they want to have these things available as services, because there's people who are good at creating these machine learning algorithms, and then there's people building the products. They don't need to be the same people, but they can interact through these APIs. The advantages are numerous. So from the data scientist perspective, you can iterate faster. You can see if a given algorithm is going to give you 80% accuracy or 20% accuracy. This is a pretty common thing, and if it's 20%, maybe that's not the right road to go down. If it's 80%, okay, now you're getting somewhere, and maybe you want to fine-tune the parameters and really put some more work into it, but now you can operate a lot faster if you can do these experiments that much faster. For application developers, it reduces complexity. It breaks out some of the most complicated parts of an application into a self-contained bit that they don't need to maintain so much. And it also, again, increases your speed and your time to market, which is an obvious advantage. And from the administration point of view, it's one less thing to maintain. It isolates, it separates concerns, and by outsourcing that, you can gain security and scalability. Again, very similar to cloud computing in general. So one of the important things when we talk about this is, why is this interesting now? And why is this relevant at the current time? And half of that equation is on the data side. There's been a huge explosion in unstructured data. And that's anything from web pages that are just natural language text, to images, to video, everything coming out of mobile, log data, transaction data, emails, social media. All of these things are generating huge amounts of unstructured data, which are not amenable to more traditional machine learning techniques. So more traditional machine learning techniques will expect numeric data that look for things like correlations and things like that. But when you have unstructured data like this, it's a whole new problem to deal with. And so the humans are the gold standard of this. Everybody intuitively understands that humans can make sense of data, and businesses obviously leverage humans extensively to do these tasks. The promise of AI is that if we can achieve human level or near human level, or in some cases even beyond human level abilities, we can automate this process, we can make it faster, we can reduce costs significantly. We talked a little bit about this before, but some of the commercial applications, the things that you can actually do with AI, ML and AI today to improve your products are things like image classification. I'm sure if you've been seeing some of the talks today, there's been a lot of examples of that. Visual search, being able to import huge amounts of video and searching for particular tags or things, searching by image is also a possibility. Face recognition, also huge. Natural language, huge amounts of text out there, and so on. So when it comes to dealing with unstructured data, the big thing that's changed in recent years, we talked a little bit about the data side of things. On the algorithm side of things, deep learning has really come to dominate the conversation when it comes to anything unstructured. I heard a quote by the CEO of Kaggle, which is a data science competition website, and he said that in general, there's basically two kinds of winners of their competitions. If the data is structured, it's usually the XGBoost algorithm that's used on it. If the data is unstructured, it's almost always a deep learning problem. For that a little bit. And so the algorithms have been advancing over the years, and there have been a couple key breakthroughs, but overall the algorithms themselves for deep learning are not that new. Overall, the big change that's really allowed a lot of gains in this area has been the hardware. And GPUs have been critical to that. They've really allowed orders of magnitude improvement, both in the available amount of computing and the amount of data that they can handle. So NVIDIA's been at the forefront of that. There's a couple examples here. There have been some theoretical advances which has allowed us to train faster and more data and so on. But really, the hardware has been the huge differentiating factor. On the Algorithmia side of things, and in general, there's been a number of startups and companies that are starting to move into this world of deep learning models hosted in the cloud. And it presents a number of unique challenges to doing this, but I'll just first kind of go through a couple examples of things that are available today, which are already being used in applications by developers out there. So when we launched, this is an example of a colorization algorithm, it takes in a black and white image and is able to colorize it by learning from thousands and thousands of pairs of these colorized in black and white images. And so that can be pretty cool. Style transfer, also this was covered in another talk earlier here, but you can use deep neural networks to transfer styles, artistic styles from one image to another. So this is using Van Gogh's Starry Night applied to a picture of Mount Fuji I found. And things like video search that I alluded to, where you can take a video, you can break it down into its individual frames, and you can automatically tag them or search for images within those tags, which enables all sorts of new applications. So when it comes to deep learning, it is important to distinguish between training and inference. So training is when you run against thousands or millions of input data points, images, or whatever it might be. Inference is when you're actually classifying or basically operating on a single one, responding to a user request, for example. Training deep learning models is challenging. There's been some talks on that here. There's been a lot of companies working on that. But the other side of the equation is actually hosting these models at scale. It's pretty easy to get a deep learning framework up and running on your laptop, train a model, and see it working. But if you're running an app that has thousands or potentially millions of users, it's a very difficult challenge to get that running on GPUs, across hundreds of GPUs in the cloud. So some of the challenges that are present in hosting deep learning models is, how do you, it's pretty new, not all of the major cloud compute providers even provide GPUs in their service offering. Amazon just recently updated their cards, And before that, it had been about 3 years since they updated their cards, and so it was pretty difficult to use it there. There's issues of memory fragmentation, there's issues of multi-user concurrency, and there's issues of data safety. I don't have enough time in this talk to go deeply into that, but it's a really interesting area. And to go back to this general topic of why do machine learning in the cloud, so I showed the example image of black and white color, the image colorizer, and we launched that as a blog post for Algorithmia, and the response was huge. We had over 200 publications talk about it. There's currently multiple iOS and Android and Photoshop plugins in the app stores to actually do this. And so this is showing some of the traffic that we got. And if you were hosting this on-premise and trying to manage it yourself with your own GPU compute farm, you would have to have enough GPUs to sustain this peak load. And basically everything here, before and after, would just be wasted resources. But by doing this in the cloud, we were able to actually keep, maybe one GPU around here, and then very quickly scale up to dozens of GPUs to handle the peak load, and then shut them down and follow user traffic. So it is a little bit more expensive, per minute or per hour in the cloud to use GPUs. But when you look at the difference being able to scale up and scale down, you can save huge amounts of money on infrastructure and on also managing all that hardware yourself. And so the final point is that this is generally how you're going to want to be structuring things anyway, is even if you said, no, I don't want to use machine learning APIs in the cloud, or for whatever reason I don't want to do that, I want to just do it in-house, you're probably going to be structuring it that way anyway. You really don't want to be putting GPUs and these heavyweight machine learning algorithms on your main web servers. As an example, you would probably be building a service that it would call out to. And this is a pretty standard design for systems these days. But it also makes it really easy that if you have this entire section of your system, which is just a service for hosting your deep learning models, it's really easy to abstract that away, offload that to something like the Algorithmia API or any number of them, which just removes that much complexity from your network stack and makes your life that much easier to deal with. So, final point, again, I kind of hit these points several times, but I strongly believe that machine learning and AI will be increasingly critical for businesses going forward. In the same way that in this day and age, you couldn't run a business without it being on the internet, without having a website and a web presence, and probably even an app in many cases. Your business would fail, you wouldn't be able to compete in the world. Similarly, we're entering a world where machine learning and AI are going to be the same. If you're a business and you're not using machine learning and AI to A, lower your costs, reduce the number of staff and people that you need to be doing to do tasks, or to be able to enable certain functionality in your apps that you couldn't do without these kinds of tools available at your disposal, you just won't be able to compete in the marketplace. And to even today, even with the amazing connectivity of the internet and the accessibility of everything, it's still very difficult to get access to state-of-the-art algorithms and machine learning. And the reason for that is partly just that there's a shortage of talent out there, and there's so much demand for it that it gets spread too thin. And there's also just the problem of, even within academia, there's not really a great system for getting this research out there and commercializable. And so finally, even if you believe those things, that machine learning and AI are going to be increasingly critical for your businesses going forward, APIs promise to solve a lot of the problems that are currently facing it. It allows multiplying effect of, if I'm a developer of algorithms, and instead of selling my work to one company as an employee, I can do the same research in computer vision or NLP and make it available to hundreds of companies. So that's really good for me as a researcher. And similarly, if I'm a company, it reduces my complexity, increases my agility, how fast I can iterate, and gives me access to all these amazing tools. So thank you for attending. This is a sign-up code for Algorithmia, which will give you $50 of free credits, which goes actually quite a long way. It'll allow you to do a lot of playing around, check out a lot of the algorithms that we have up there, play around a bit. And thank you for attending my talk.
Okay, thank you very much for this talk. So do any of you has questions? Okay.
Great talk. Just a quick question. In traditional algorithm, like if you look at the Dijkstra algorithm or even a naive Bayes classifier from kind of machine learning, the algorithm is somewhat static or fixed. In other words, you know that this is how you do the algorithm, you read the Wikipedia page, you code it, you're done. In that case, it's very clear how Algorithmia would work. Deep learning, on the other hand, for example, is actually a paradigm more than it is an algorithm, whereby there's infinitely many algorithms of a deep learning type. And so when you're constructing the deep learning network, you would actually go in and have many layers specific to your product where you change the whole mathematical equations. In one case, you use Boltzmann machines, another way like Gibbs sampling, and in another way maybe some Brownian motion thing mixed in with those other two, which take data inputs in different ways. So in this case, when a company wants to use Algorithmia in the deep learning case, you want to be able to modify or construct the algorithm, if you will. Maybe have a starting point, but it's going to be very kind of customizable algorithms now, it seems, as we go forward. So does Algorithmia, for example, have a plan to do that, or maybe it already exists?
Yeah, absolutely. So that's a good question, and maybe I glossed over a little bit. Neural networks would not be considered a single algorithm on the Algorithmia platform. It's actually each individual model that you develop would be sort of considered its own endpoint, its own individual algorithm. And so, yes, there's a whole wide variety of different neural network structures and the way that you format the inputs to them and doing the training. But overall, there is actually not that many different ones. And a research lab will come up with an idea, whether it's the colorizer or whether it's a translation network or any of those things. And that network in itself is actually not that changing. You might make tweaks to it in some cases, but overall that actually is more static. It just depends more on what the input data and the output training set is. So that's part of it. Generally speaking, the networks actually don't change that much. Most people will just take an off-the-shelf network, things like GoogleNet, LayNet, VGG, or any of these ones that are out there, and just go with that. With maybe some very minor tweaks, but that's actually the minority, and that's more in the academic world than really in the commercial world in our experience.
Okay, thank you very much. I'm really sorry we have to end the session. So let's give Kenny Daniel a big applause again. Thank you.
Great, yeah.
We actually reached out to the rest of us.